Okay, so we have an example here. It says, given the function f of x, blah, blah, determine the x values for which the function values are negative. I'm going to take two approaches to this. I'm going to look at it graphically, and then I'm going to show it to you algebraically, just so that you can see that. All right, so let me slide this up because it's going to take a little room to do the graphing part of it. If I wanted to look at this graphically, I would think about, well, when does the function equal 0? Now, when I figure that out, that'll tell me exactly where I'm at on the x-axis. We know it's an absolute value function. We know it makes some kind of v, right? Okay. So let's go ahead and solve this. You'd have -1/2 absolute value of 4x minus 5 equals -3. Multiply both sides by -2. Oops, where'd that negative come from? Because I said -2 probably. Okay, 4x minus 5 is equal to 6, right, if you multiply both sides by -2. And then you could say, well, 4x minus 5 equals -6, or 4x minus 5 equals +6. This is going to give us those two places where the two values of x where it would actually equal 0. Okay, so if I add 5 here, and I divide by 4, and on the other one, if I add 5, and I divide by 4, I get this happening. Now, I'm going to scroll. Okay, so what does it mean? It means I have somewhere, you know, at -1/4, it's crossing right there. -1/4, 0 is a point on this graph for this function. And it also means, let's see, 11/4, what's that? Almost 3. So 1, 2, 3, so like right there. That would be the point 11/4, 0. Now, how is it working? It's a v. If you go back to the original function, right? What does that -1/2 say? That -1/2 says it's going to be upside down, right? Okay, so let's go back to this. Wherever it's in between, I'm just going to kind of eyeball it. Somewhere in there, though, it's going like this, right? We know it's a V. I don't have it exactly where the vertex is, but I know it looks something like that. So what did the question ask me? Now I got to scroll up and see. It says determine x values for which the function values are negative. So it's going to be negative in here, and it's going to be negative in here. What are those x values? Well, it looks like anything less than -1/4. So from -infinity to -1/4. Just less than? I think just less than, no equal to, right? I'll go back and look. Union, and then it's going to be from 11/4 to infinity. Okay? So graphically, we can see the solution that way. That might not be the easiest way to look at it. And by the way, your book uses decimals. I would just use the fractions, but okay. And then we write that in the interval notation. Now let's look at it algebraically. Okay, so we're going to scroll up, and we're going to go the algebra way. So we're saying we want this function to be negative. -1/2 absolute value 4x minus 5 plus 3 is, let's see, we want it to be negative, less than 0. Okay, so now it looks like a less than, but watch what happens. You have a -1/2. You've got to isolate the absolute value part. There's no switching of the sign there because all we did was subtract 3 from both sides. Okay, now we're going to multiply both sides by -2. So I'm multiplying over here by -2, and I'm multiplying over here by -2. I didn't write that out before, but you're going to get absolute value of 4x minus 5 is greater than 6. Because you multiplied by a negative number, you've got to switch the inequality the other way. Okay, so now we have a greater situation, greater or. either that stuff inside the absolute value is less than -6. Don't forget to make it less than the negative case. Or that stuff inside the absolute value, it's called the argument, is greater than +6. And then we can solve those. So 4x is less than -1, or x is less than -1/4, or 4x is greater than 11, x is greater than 11/4. So algebraically, we get the same answer. And I don't know which way is easier for you to do. It's nice to look at the graphic representation of it. By the way, my graph is supposed to be a V, not a U, so I didn't draw that very well. Or if it's easier to just do it algebraically. For me, I'd probably just do it algebraically, but it's nice to look at the graph because it gives us a better understanding of what's going on, putting the pieces together. Okay.